For most of human history, darkness seemed like a safe and familiar place. We told stories under the stars and found comfort in their silent glow. Yet hidden between those stars are monsters, not made of flesh, not even of light, but of gravity, of radiation, of the coldest emptiness imaginable. Space is not peaceful. It is a battlefield of extreme energies and ancient ruins, a stage where entire suns are born and then ripped apart. If our eyes could see beyond visible light, the night sky would look nothing like the calm we know. It would blaze with invisible storms, bursts of gamma rays, clouds of lethal particles, relics of explosions so powerful they echo across millions of light years. Right now, the Earth rests in a narrow pocket of safety, a fragile island of warmth and air. But step beyond it and the quiet dark becomes a hostile ocean. Everything out there is moving, colliding, devouring. The stars may look peaceful, but they are only the surface of something terrifying. This is where our journey begins, past the thin veil of beauty into the real universe, a place stranger, darker, and far more dangerous than we ever imagined. The night sky feels calm only because we're blind to most of it. Our eyes were built to see a narrow band of light, a safe, familiar glow. But outside that fragile slice of reality, the universe is boiling. Invisible radiation flashes across the void. Shockwaves ripple through intergalactic gas. Explosions brighter than the entire galaxies roar in wavelengths our eyes can't detect. What we call darkness is not empty. It is alive with forces so violent they could erase entire worlds without warning. Gamma ray bursts fire like cosmic sniper shots. Black holes swallow light itself. Magnetars flex their invisible strength strong enough to rip atoms apart. If we could see everything that truly happens out there, the sky above us wouldn't look peaceful. It would look like a battlefield, a storm of light energy and gravity beyond comprehension, and we're standing on the edge of it, barely aware of the monsters watching from the dark. The only reason we're still here to look up is because Earth hides behind an invisible shield. A magnetic field deflects radiation. A thin atmosphere softens cosmic impacts and sunlight warms us gently instead of burning us alive. But that shield is paper thin on the scale of the cosmos. A few hundred kilometers above us it ends. Beyond that line there are no safe skies, only cold vacuum and radiation. The sun turns harsh. Cosmic rays become constant. Temperatures swing between burning heat and killing cold. It is not a welcoming place. This thin border is the last calm shoreline before the black ocean. Step beyond it and the quiet night sky becomes a hunting ground, and waiting in that darkness, silent and patient, is the most terrifying predator in the universe. The first monster has no face, no surface, no mercy. A black hole. They do not shine. They do not roar. They do not announce their presence with light. A black hole is the purest shadow in existence. A tear in the fabric of space-time, a place where gravity grows so intense that nothing, not even light itself, can escape. Around it, the universe bends like soft metal under immense pressure. Inside time and space switch roles, and the idea of coming back stops existing. Black holes are born when massive stars die in violent supernova explosions. If the remaining core is heavy enough, it collapses under its own weight, falling endlessly inward. There is no solid object at the center, only a point, a singularity where the known laws of physics break down. Surrounding this point is the event horizon, a one-way border. Cross it and escape becomes impossible. But what makes black holes truly terrifying is not just their power, it's their silence. They drift through space like invisible traps. You wouldn't see one coming. There's no light to warn you, no glowing sign. A black hole can lurk in the dark, pulling in stars, gas, even entire clusters, swallowing everything without leaving a trace. They come in many sizes. Some are just a few times heavier than the sun. Others at the centers of galaxies hold the mass of millions or billions of suns, and they are always hungry. Anything that drifts too close is lost forever. The night sky is filled with these silent predators. Some shine indirectly through the violence they cause, others hide in perfect darkness. And the closer we get to one, the stranger and more horrifying reality becomes. Every black hole hides behind an invisible wall. It isn't made of stone or fire. It's a boundary in space-time, the event horizon. Cross this line and the universe gives you no way back. Not even light can outrun the pull once it steps past that edge. To an outside observer, anything falling toward the horizon slows down, stretching in both space and time. It fades, reddens, and seems to freeze just above the edge as if trapped forever. But from the point of view of the falling object, nothing special happens. 1 second you're outside, the next, the rest of the universe is gone. Time and space have flipped roles. The future lies inward and escape has been erased from reality itself. What makes this border terrifying is how ordinary it looks from far away. A black hole doesn't roar when you cross its threshold. It doesn't flare with light. It swallows you silently without drama. If Earth were to fall toward one, we wouldn't see the surface crumble. We'd watch it stretch slow and disappear into the dark. The event horizon isn't a wall you crash into. It's a promise the universe keeps. Once you pass through, your story ends in one direction, only down. The closer you get to a black hole, the more gravity stops behaving like anything familiar. It doesn't just pull, it stretches. If your feet were closer to the black hole than your head, the pull on them would be stronger, far stronger. Your body would be stretched along the direction of gravity and squeezed from the sides at the same time. Astronomers call this tidal force. The result has a name that sounds almost playful, but it isn't. It's called spaghettification. As you fall inward, this difference in gravitational pull grows exponentially. First your body would elongate, then your molecules, then even your atoms would be ripped apart. The forces are so extreme that they shred matter at the most fundamental levels. And there's no sudden crash or burning impact. You wouldn't hit anything. You'd simply be pulled into a shape the universe doesn't forgive, stretched thinner and thinner as you accelerate toward the singularity. From the outside, it would look like you were frozen near the event horizon. From your own point of view, you'd plunge inward faster and faster into a darkness no signal can escape. This is the true face of a black hole. Not fire, not explosion, but quiet, unstoppable gravity. A force that doesn't just crush planets or stars, it dismantles the very structure of matter itself. Black holes themselves emit no light, but their presence warps everything around them. When gas dust or even entire stars drift too close, they don't fall in quietly. They form a whirling storm, a disk of matter spiraling inward at a fraction of light speed. This is the accretion disk, one of the most violent structures in the cosmos. The gas inside it doesn't just glow, it roars. As it spins faster and faster, friction and compression heat it to millions of degrees. It releases torrents of radiation in ultraviolet and X-rays, making these invisible monsters visible. The disk becomes a blinding ring of light wrapped around a perfect shadow. This is not a gentle orbit. The material is being shredded apart atom by atom, accelerating toward an inevitable end. Magnetic fields twist and snap like cosmic whips. Space itself bends sharply near the event horizon, curving the path of light. To a distant observer, the disk seems to smear and warp as if reality is being pulled into a whirlpool. Some black holes are quiet, feeding slowly in the dark. But others, the ones at the centers of galaxies, are gluttons. They consume matter at furious rates, creating accretion disks so bright they outshine entire galaxies. A single black hole can turn the heart of a galaxy into a beacon seen across billions of light years. What makes this terrifying is the paradox. The brightest objects in the universe are powered by the darkest things within it. A black hole doesn't just destroy, it creates a storm of light that signals its hunger. Some black holes don't just swallow, they spit. When the spinning accretion disk grows hot and chaotic, intense magnetic fields thread through it, twisting like coiled steel. These fields focus and launch twin beams of plasma straight out from the black hole's poles. They travel at nearly the speed of light. These are relativistic jets, among the most destructive forces in the cosmos. A jet can stretch across entire galaxies. It carves through interstellar space like a spear made of radiation and charged particles. If one were aimed at Earth from even thousands of light years away, it could strip away the atmosphere and sterilize the surface in seconds. But we would never see it coming. These jets are so powerful they can reshape their host galaxies. They heat and stir intergalactic gas, shut down star formation, and leave behind scars millions of light years long. Some of them blaze so fiercely they outshine everything else in their galaxy combined, and yet they are born from silence. A black hole pulls matter in, twists it into fire, and launches a weapon that cuts across the universe. No intention, no warning, just physics. The universe doesn't need monsters to be cruel. Its laws are enough. Every so often, somewhere in the universe, a star dies so violently that it doesn't just collapse, it fires a beam of pure energy across space. This is a gamma-ray burst, the most powerful explosion known. In just a few seconds, it can unleash more energy than our sun will emit in its entire lifetime. These bursts are not gentle flares. They are narrow focus jets moving at nearly the speed of light. If Earth were ever unlucky enough to lie in the path of one, the atmosphere would be stripped away and the planet would be sterilized in an instant. There would be no warning, no escape. By the time we saw it, it would already be over. Some gamma-ray bursts are born from massive stars collapsing into black holes. Others erupt when two neutron stars smash together. For a few heartbeats of cosmic time, the universe fires a weapon of unimaginable power, then goes silent again as if nothing happened. Astronomers have detected these bursts from billions of light years away. They're so bright that their light crosses the universe to reach us long after the galaxy that spawned them may have changed beyond recognition. And that is perhaps the most chilling part. These cosmic sniper shots don't need to aim. They only need to happen. If black holes rule through gravity, then magnetars rule through magnetic fury. A magnetar is a kind of neutron star, a dead collapsed core of a massive star but with a magnetic field so intense that it makes even the strongest magnets on Earth meaningless. Its field is trillions of times stronger than Earth's, powerful enough to twist and tear atomic structures apart. Stand anywhere near it, even from a distance of hundreds of thousands of kilometers, and your body's atoms would be stretched and distorted by the magnetic force itself. Matter doesn't behave normally around a magnetar. Even empty space bends slightly under its influence. Sometimes the crust of a magnetar cracks under its own magnetic stress, releasing sudden bursts of energy called starquakes. In a fraction of a second, one of these bursts can outshine every other X-ray source in the sky. If one were close enough, it could fry electronics, blind satellites, or even damage Earth's atmosphere. Magnetars don't last long. Their intense fields decay over tens of thousands of years, a blink in cosmic time. But during their brief, violent lives, they are among the most dangerous objects in the universe. Not because they move fast or attack, but because they simply exist quietly, warping everything around them. These are stars so extreme that even black holes give them respect. Before a star becomes a magnetar or collapses into a black hole, it can take on a form that defies everything we know about matter, a neutron star. These are the remnants of massive stars that exploded as supernovae, leaving behind cores so dense that gravity forces electrons and protons to fuse into neutrons. What remains is a sphere no wider than a city yet heavier than the sun. A single teaspoon of neutron star material would weigh billions of tons on Earth. Its gravity is so intense that if you stood on the surface, if that were even possible, you would be crushed flat in less than a heartbeat. Time itself would run slower at your feet than at your head. Space is bent so sharply that light struggles to escape. But neutron stars aren't just dense, they're fast. Some spin hundreds of times each second, whipping their magnetic fields through space like lighthouses of death. Their beams of radiation sweep across the cosmos, and if those beams pass over Earth, we detect them as pulses, rapid, rhythmic bursts that beat like cosmic drums. These stars are stable only because the pressure of neutrons pushes back against gravity, but they live on the edge. Add too much mass and that balance collapses. The neutron star implodes and a black hole is born. They are neither living nor dead, just frozen monuments of stellar violence, marking the line between matter as we know it and something far stranger. Sometimes two neutron stars locked in a deadly orbit spiral closer over millions of years. They circle faster and faster, whipping space itself into ripples. Then, in their final seconds, they crash together in a colossal explosion called a kilonova, a moment so violent it forges the heaviest elements in the universe: gold, platinum, uranium. This is not just an explosion of light, it is an event that shakes space-time. Gravitational waves burst outward, carrying the signature of the collision across galaxies. The energy released is beyond comprehension, enough to momentarily outshine entire galaxies in the infrared. For any world near such an event, there is no survival. A storm of gamma rays, radiation, and high-speed debris would scour everything in its path. Planets would be stripped bare, atmospheres obliterated, oceans boiled. Yet from that destruction comes creation. Every gold ring, every trace of heavy metal on Earth is the relic of a cosmic disaster like this long before our planet formed. These collisions are rare, but their echoes shape galaxies. The universe does not forge beauty gently. It forges it with unimaginable violence. When a massive star reaches the end of its life, it doesn't fade away quietly. Its core collapses in an instant and the star erupts outward in a supernova, one of the brightest and most destructive events in the universe. In a few seconds, it releases more energy than the sun will emit in billions of years. The collapsing core triggers a shockwave that rips through the star's layers, blasting them into space at incredible speeds. Radiation floods outward, lighting up its host galaxy like a cosmic flare. For weeks or months, one dying star can outshine everything else around it. But for any nearby worlds, this is not a spectacle. It's the end. A supernova within a few dozen light years could strip Earth's ozone layer and flood the planet with deadly radiation. Even farther away, it can disturb atmospheric chemistry and trigger mass extinctions. The universe doesn't need to aim, its reach is enormous. Yet supernovae are also the reason we exist. They scatter the heavy elements that make up planets, oceans, and life itself. Iron in our blood, calcium in our bones, oxygen in the air, all born in dying stars. These explosions are both executioners and creators, carving the universe into something new. Every glittering star we see carries a quiet promise. One day it will either fade into darkness or end in fire. A supernova is devastating. A hypernova is worse. When an extremely massive star, dozens of times heavier than the sun, collapses, its death doesn't just tear itself apart, it detonates with a force that dwarfs ordinary supernovae, releasing up to 100 times more energy. Hypernovae are believed to be one of the main engines behind long-duration gamma-ray bursts, those deadly focused beams that can sterilize entire worlds from thousands of light years away. For a few terrifying seconds, they outshine everything else in their galaxy. The light they release travels for billions of years, carrying the fingerprint of destruction across the cosmos. Near the collapsing core, space and matter are ripped into chaos. A black hole often forms at the center, surrounded by a searing maelstrom of plasma. Twin jets punch through the dying star, drilling their way into the surrounding space like cosmic weapons. Any nearby planet is simply erased. What makes hypernovae so frightening is their combination of scale and speed. They give no warning, no time to react. A star can burn steadily for millions of years, and then in less than a heartbeat it becomes a cosmic cannon firing energy across the void. These are not rare curiosities. They are part of the life cycle of the universe, scattered among distant galaxies waiting to detonate, and their echoes reach us long after the original star is gone. When a massive star dies in a supernova or hypernova, the blast doesn't just vanish into silence. It leaves behind a chaotic graveyard, a supernova remnant where shockwaves race outward, sweeping and sculpting the surrounding space. These expanding shells of gas and dust glow with energy, lighting up the darkness long after the star itself is gone. The explosion hurls heavy elements across light years, seeding the galaxy with iron, carbon, and oxygen, the raw ingredients for new stars' planets, and eventually life. But it also stirs the interstellar medium into turbulence, compressing gas clouds, and sometimes triggering the birth of entirely new stellar systems. Creation and destruction are tangled here, inseparable. Inside the remnant, what's left of the star becomes something extreme. A neutron star, a magnetar, or a black hole. Around it, radiation lingers powerful enough to sterilize worlds unlucky enough to be nearby. Long after the explosion fades from sight, the region remains dangerous, soaked in high-energy particles. These scars in space are beautiful from a distance, vast, glowing, and silent. But up close they are still hostile, still violent, still echoing with the last breath of a star that died like a god. In the universe, death doesn't simply end. It spreads. It reshapes everything that comes after. Not all these stellar catastrophes happen in distant galaxies. Some lurk uncomfortably close by scattered across our corner of the Milky Way. Astronomers have identified several nearby supernova candidates, stars massive enough to explode within the next few million years. That may sound distant, but in cosmic terms it's tomorrow. One of the most closely watched is Betelgeuse, a red supergiant more than 600 light-years away. It's expected to go supernova someday, lighting up our sky brighter than the full moon. At that distance, it wouldn't destroy Earth, but its radiation would still ripple through our atmosphere. And Betelgeuse isn't alone. Other massive stars like Antares or Rigel also sit quietly ticking like cosmic bombs. Closer still, we've found remnants of past explosions, bubbles of hot gas and radiation from ancient supernovae that went off near the solar system. One of them likely helped carve out the cavity of space our sun currently sits in, the local bubble. These blasts shaped the environment around us long before humans ever appeared. We live in a quiet region of the galaxy, but not an untouched one. Space around us remembers violence, and one day that quiet may be broken again by a nearby star's death scream. The monsters of the cosmos don't always hide far away. Some of them live in our neighborhood. Long after a star explodes, the brilliant light fades, the glowing nebula cools, and the shockwaves slow. But gravity remains. The core left behind, whether a black hole, a neutron star, or a magnetar, continues to shape everything around it for millions, even billions of years. These stellar remnants are like cosmic traps left in the dark. A black hole that formed long before humanity existed could be wandering through interstellar space right now, invisible to telescopes, unless it disturbs something nearby. A neutron star, barely 20 kilometers across, can still bend the path of light from distant stars, warping space with its intense mass. The terrifying part isn't their violence in the moment of birth, it's their endurance. Long after the flash is gone, they remain silent, patient, waiting. A star can die in seconds, but the remnants it leaves behind can outlast entire civilizations. The night sky we see is full of their ghosts. Behind many faint points of light lie these dark legacies, relics of stars that burned, exploded, and left behind something far stranger than what came before. This is how the universe keeps its scars. Not on its surface, but in its gravity. A black hole doesn't need to shine to be deadly. Most drift silently through the galaxy, invisible, unless they reveal themselves by warping nearby starlight or pulling matter from a passing cloud. These are the dark wanderers, remnants of ancient stars long dead, moving unnoticed through interstellar space. Unlike stars, they emit no steady light. They could be anywhere, even closer than we realize, and we might never know until something crosses their path. A star passing too near could be torn apart in what astronomers call a tidal disruption event, where stellar material is shredded and whipped into an accretion disk, briefly lighting up the black hole like a flare in the night. But not every encounter is that dramatic. Many black holes may simply pass by, bending the fabric of space-time, tugging at orbits, disturbing the invisible structure of our region of the galaxy without a sound. This is what makes them terrifying. They don't need to roar to kill. They wait in the dark, patient, invisible, and unstoppable. And somewhere out there, countless of these cosmic predators are still roaming. Most of the monsters in the cosmos don't shine. They don't glow like stars or flare like supernovae. They slip through the galaxy without a trace, their presence betrayed only by how they bend the space around them. These are the dark wanderers, black holes formed from long-dead stars drifting through interstellar space like silent predators. Unlike the supermassive black holes that anchor the hearts of galaxies, these are smaller, stellar mass black holes, remnants of stars that lived, died, and collapsed under their own gravity. Over cosmic time, they lose their fiery birthmarks and fade into nothingness. They emit no light, no heat, no radiation strong enough for our telescopes to detect. A nearby black hole could be passing through the outskirts of our solar neighborhood right now, and we might never know. We only catch them when they give themselves away, when a star happens to wander too close, or a drifting cloud of gas is pulled into their gravity well. The star is stretched and shredded, its outer layers ripped away in a process called a tidal disruption event. For a brief moment, the black hole flares to life, surrounded by an accretion disk blazing in X-rays. And then as quickly as it appeared, the light fades and the trap goes quiet again. But the truly terrifying thought isn't the rare burst of light, it's the silence. A black hole passing through a region of space doesn't need to devour anything to change everything. Its gravity alone can tug at orbits, destabilize planetary systems, or fling comets from their quiet paths into chaotic journeys. Over long timescales, a single encounter could reshape entire star systems or erase them completely. The Milky Way likely holds hundreds of millions of these unseen monsters wandering between the stars. They don't roar, they don't burn, they wait. And because they are invisible, there is no warning, only the sudden moment when something begins to fall. Out here, light is a luxury. In the dark, gravity rules. The closer anything drifts toward a black hole, the less familiar time becomes. This isn't science fiction, it's a direct consequence of how gravity bends space-time. As you approach a massive object, time slows down. Near a black hole, it stretches to the breaking point. From a distance, an object falling toward the event horizon seems to move slower and slower. Its signals are redshifted, its image fades, and it appears to freeze just above the edge. But this is only an illusion seen from afar. From the object's own perspective, nothing unusual happens at all. It simply keeps falling, and in a heartbeat the rest of the universe is locked behind it. This warping of time isn't subtle. Near a supermassive black hole, minutes close to the horizon can equal years or centuries for observers far away. A human standing safely distant would watch someone fall and vanish in silence frozen in time. But the person falling would never feel that pause. For them, the flow of time remains smooth and cruel. This means that black holes don't just consume matter. They consume time itself. Anything that crosses their threshold is dragged into a future that can't be shared with the rest of the universe. Whatever story begins at that edge ends alone inside a world where time has lost all meaning. And time doesn't just bend around black holes. It bends around every massive object, stars, planets, entire galaxies. But only here does it tear. In the warped fabric of space-time, the black hole is not just a hole in space. It's a pit in the river of time. This is what makes these cosmic predators unlike anything else. You could in theory watch someone fall forever, but they inside that gravity well would already be gone. The event horizon isn't just a border in space, it's a fracture line in time. From the outside, anything falling toward it slows. Its light stretched into deep red until it fades away. But from the inside, the fall is silent and absolute. Space folds inward like arrows on a collapsing map. Time stops being a direction. You can choose, it becomes a single unavoidable future. The singularity. A black hole doesn't pull you in like a monster. It pulls time itself forward, and you have no choice but to follow. Before anything crosses the horizon, its light dies first. Photons climb the gravity well, losing energy step by step, turning red, then fading into silence. It's not a scream, it's an erasure. A black hole doesn't hide what falls into it. It slowly unwrites it from the universe, leaving only darkness where light once was. Time near a black hole doesn't just slow down, it fractures. A traveller orbiting close to the horizon could live minutes while centuries pass far away. A voice shouted from near the edge would stretch and fade like an echo trying to crawl out of gravity's grip. The closer you are, the more the rest of the universe slips ahead into a future you'll never reach. This isn't just a trick of perception, it's the true shape of time when space itself is bent. Outside a spinning black hole, space itself begins to twist a region called the ergosphere. Here matter swirls in a glowing disk, heated to unimaginable temperatures as it spirals inward. Some of this energy is stolen back from the hole hurled into space as thin, blinding jets. It's one of the few places in the cosmos where even a black hole can be robbed of its power. But step too close, and the same storm that lights up galaxies will swallow you forever. This isn't just a strange trick of perception, it's real physics. A clock placed near the horizon would tick slower than any clock farther away. Signals exchanged between the two observers would be warped, stretched, delayed. A voice sent from the outside would reach the inner orbit as a slowed, deepening echo, and the voice sent outward would climb the gravity well, losing energy, fading into silence. This effect is small near planets or stars, but around a black hole it's overwhelming. A single orbit close to the horizon could leapfrog centuries of cosmic history. Entire civilizations could rise and fall while a traveller near the black hole experiences only a short span of time. This makes time itself a kind of trap, not only because escape is impossible once you cross the horizon, but because even brushing against it disconnects you from the universe. Step too close and the world you know races beyond reach. Around a black hole, time is not your ally. It's a weapon, silent, invisible, and absolute. Far from the blazing hearts of stars and the violent flare of black holes, there are places in the cosmos where almost nothing happens. No light, no heat, no sound. These are the cold regions of interstellar space where temperatures drift toward absolute zero just a few degrees above it. Here the universe reveals a different kind of terror. Not violent destruction, but endless emptiness. In these regions, space isn't completely void. A few atoms float in every cubic meter, relics of ancient stars and galactic winds, but they are so thinly spread that collisions between them are rare. A single particle might travel thousands of years before meeting another. There is no air to breathe, no light to see, no warmth to hold. It's a silence deeper than anything the human mind can truly grasp. The cold isn't just physical, it's cosmic. Light from distant stars weakens as it travels stretched and thinned until only faint whispers remain. Even the afterglow of the Big Bang, the cosmic microwave background, bathes these regions in a faint uniform chill at just under 3 Kelvin. This radiation is the last faint warmth of the early universe, a ghost of creation itself still drifting through the dark. No world could survive here. A spacecraft without power would become an icy tomb. Metal would contract and crack. Electronics would fail. Molecules would slow to near stillness. The idea of life as we know it becomes meaningless. This is the quiet other face of the universe. Not fire, not fury, but the absolute indifference of a cosmos that keeps expanding and cooling. The longer the universe lives, the more of it becomes like this cold, dark, and silent. A universe where the monsters don't need to roar anymore because nothing is left to hear them. Between galaxies lies a darkness far deeper than anything near our sun. It's called intergalactic space, the vast regions between clusters of stars where matter thins out to almost nothing. In these enormous stretches, a cubic meter of space may hold just a handful of particles. Radiation drifts silently. No planets orbit here, no stars burn. It is the closest thing to true emptiness that our universe allows. In these voids, temperature sinks to just above absolute zero, and light from distant galaxies is stretched so thin by cosmic expansion that it becomes nearly undetectable. The distances are so immense that even travelling at the speed of light, it would take hundreds of millions of years to cross. These are not places built for life or warmth. They are the dark lungs of the cosmos where silence reigns and time seems to stand still. It's easy to imagine the universe as full packed with stars, planets, galaxies. But in truth, the opposite is real. Almost all of it is made of empty space. Galaxies are scattered like tiny islands in a black ocean, separated by gulfs so enormous they make the Milky Way feel small. If a single galaxy were a bright lantern, the void around it would be an endless desert. A spacecraft lost here would have no landmarks, no signals, no return path. Its transmissions would take eons to reach anyone if they ever did. In these voids, the universe doesn't just feel distant, it is distant. It doesn't fight you. It doesn't need to. It waits in perfect stillness, because nothing survives long in places where there is nothing at all. The terrifying part of the cosmos isn't always what's violent. Sometimes it's the silence. Sometimes it's the endless empty dark. Among all the empty regions of the universe, one stands out as a silent giant. The Bootes Void. Discovered in the 1980s, it's one of the largest known voids in the cosmos. A vast sphere of darkness nearly 330 million light-years across. To grasp its scale, imagine placing thousands of Milky Ways side by side and still having room to spare. This region isn't completely empty. A few dozen galaxies drift inside it like lonely ships on a black ocean. But compared to the cosmic average, it's astonishingly bare, a desert in space, where even gravity seems to have nothing to hold on to. For any hypothetical traveller, this void would be a nightmare. Light from distant galaxies would be so faint it might as well not exist. Directions would lose meaning. A sense of isolation would become absolute. What's most unnerving is not just its size, but how such a thing can exist. Voids like Bootes formed as matter in the early universe clumped together under gravity, leaving behind vast regions nearly empty. Over billions of years, galaxies gathered into walls, filaments, and clusters the cosmic web, while places like Bootes became colder and lonelier. If you were floating at the centre of the Bootes Void, the night sky would be almost blank. No Milky Way overhead, no nearby stars, only a faint sprinkle of light so far away it could never be reached within a lifetime. It would feel less like being in space, and more like standing outside the universe entirely. This is not just empty space. This is the architecture of nothingness on a cosmic scale. A place so vast, so silent that even the universe itself seems to fade away inside it. Voids like Bootes Void are not random holes in space. They are part of a far larger pattern, a vast cosmic web that stretches across the observable universe. Galaxies, clusters and filaments weave together to form something that looks less like a collection of stars and more like a living structure, an immense three-dimensional network of light and darkness. At its largest scales, the universe isn't evenly filled with matter. Instead, gravity has pulled it into walls and filaments, long strands of galaxies that can stretch hundreds of millions of light-years. Between them lie enormous empty voids, cosmic caverns where almost nothing resides. If you could step back and see the universe as a whole, you wouldn't see a smooth expanse of stars. You'd see something more like a spider's web spun from galaxies. This structure began with tiny fluctuations in the density of matter in the early universe. Over billions of years, gravity amplified those ripples, pulling material together into the cosmic scaffolding we observe today. Galaxy clusters lie at the intersections of these filaments like glowing knots in a dark net. The voids between them are not just absences, they're the result of matter being drawn away into denser regions, leaving behind vast hollow expanses. It is a strange, unsettling sight to imagine. A universe where most of space is empty, and all the galaxies we can see are strung along thin threads in an infinite silent web. The structure is so large that light itself takes ages to traverse it, and even though we've mapped much of it, we still don't fully understand what invisible forces shaped its skeleton. The cosmic web is beautiful from a distance, but it's also a quiet reminder. Our galaxy is just one glowing bead on a strand of something unimaginably vast. And around those strands, the darkness is endless. Our galaxy is not floating aimlessly through space. It's being drawn along with billions of other stars, planets, and entire clusters towards something massive hidden behind a veil of dust and darkness. Astronomers call this mysterious region the Great Attractor. It lies roughly 250 million light-years away, and its gravitational pull is powerful enough to drag entire galactic superclusters in its direction. This isn't a single object like a black hole or a star, it's a gravitational anomaly, a vast region of extraordinary mass buried within the plane of our galaxy, where visible light can't easily pass. What makes it so unsettling is that we can feel its pull, but can't fully see what's doing the pulling. The Milky Way Andromeda galaxy and countless others are all drifting toward it at hundreds of kilometers per second. The space around this region isn't calm. Galaxies are streaming through the cosmic web like rivers, their motions subtly bent by the Great Attractor's gravity. It's as if an invisible whirlpool exists in the fabric of the cosmos, tugging at everything around it. And because of its location, partly hidden in what astronomers call the zone of avoidance, we still don't fully understand what lies at its heart. Later discoveries revealed even larger structures beyond it, like the Shapley supercluster, suggesting the Great Attractor may be just part of a much grander gravitational landscape. But the effect is clear. The entire Laniakea supercluster, including our own galaxy, is slowly falling towards something colossal and unseen. It's one thing to fear black holes or violent stars. It's another to realize that our entire cosmic neighborhood is moving toward a hidden destination, and no one can stop it. The Great Attractor isn't the end of the story. Beyond it lies an even more massive structure, the Shapley supercluster, a colossal concentration of galaxies and dark matter, more than 500 million light-years away. It contains thousands of galaxies, each home to billions of stars. Its gravitational pull is so overwhelming that it tugs on entire galaxy clusters, reshaping the large-scale flow of matter through the universe. What makes Shapley terrifying isn't just its size, it's the way its gravity extends across hundreds of millions of light-years, bending the motion of galaxies like invisible hands. We are not standing still in the cosmos. Our galaxy, along with the entire Laniakea supercluster, is slowly drifting toward it at hundreds of kilometers per second. Whether we want to or not, we are part of a gravitational current that has been flowing for billions of years. Shapley is so massive that it warps the cosmic web around it. Galaxies don't orbit it like planets around a star. Instead, their paths are subtly bent and accelerated by its sheer weight. Over time, these movements sculpt the invisible architecture of our region of the universe, and yet we have never truly seen Shapley in full. It lies partly hidden, and its exact boundaries remain difficult to map. This is a different kind of fear. Not the fear of sudden destruction, but of inevitable motion. We are passengers in a silent river of galaxies drifting toward a gravitational giant we can't escape and can barely comprehend. This journey is slow on a human timescale, but relentless on a cosmic one. The universe does not need to chase us. It only needs to keep pulling. All the flows of galaxies, the pull of the Great Attractor, the distant tug of the Shapley supercluster, the rivers of motion threading through the cosmic web converge into one grand structure, the Laniakea supercluster. This is the vast cosmic basin that our galaxy calls home. Laniakea spans more than 500 million light-years, encompassing around 100,000 galaxies. Every one of them, including Milky Way, moves not at random but along curved invisible highways of gravity. These highways are shaped by the distribution of both matter and the elusive dark matter that outweighs it. Like rivers draining toward a great sea, the galaxies flow inward toward regions of deepest gravitational potential. What makes this unsettling is the scale. The entire Milky Way, the Andromeda Galaxy and countless others are caught in this slow drift like leaves on a black cosmic tide. There is no engine pushing us forward, no choice, no control. We are being pulled along by gravity written into the structure of the universe itself. If you could step far enough away to look at Laniakea in its entirety, it would look like a vast branching basin of galaxies with filaments like rivers and clusters, like lakes, all draining toward gravitational depths. But from where we stand inside one of its spiraling currents, it's impossible to feel the motion directly. We are travelers who don't even sense the journey. Laniakea is not a monster in the traditional sense. It won't burn or crush us, but it reminds us of something more chilling. The universe is not still. Everything is being carried somewhere, and in the end we are passengers on a current far larger than ourselves. Even as galaxies stream along the strands of the Laniakea supercluster, most of space remains utterly empty. Between these filaments and clusters lie immense interfilament voids regions where gravity is weak, and the cosmic expansion pushes galaxies farther apart instead of pulling them together. This is where the true quiet of the universe lives. In these places, temperatures hover just above absolute zero. No stars form here, no galaxies grow, no gravitational structures take shape. Over billions of years, the cosmic expansion will make these voids grow larger, still isolating clusters of galaxies like shrinking islands in an ever-widening ocean of black. The edges of these voids are shaped by invisible hands, not only by the mass of galaxies themselves, but by dark matter, the hidden scaffolding beneath the cosmic web. This unseen mass defines the contours of the universe, creating gravitational valleys where galaxies gather and high plateaus where they flee. If we could map dark matter directly, we would see not a blank void, but an intricate, ghostly landscape of gravity stretching across the cosmos. Floating in the middle of one of these voids would be unlike anything imaginable. No nearby stars, no planets, no sense of direction. The night sky would contain only a faint smear of distant light too far to ever reach. This is the universe stripped of everything warm, everything familiar, a place where expansion itself wins, not because it's violent, but because there is nothing left to resist it. The cosmic web gives the illusion of a crowded universe, but the truth is more haunting. Most of existence is emptiness growing larger every day. Beneath everything we can see stars, galaxies, and glowing filaments. There exists a hidden structure shaping the cosmos. It isn't made of light or ordinary matter. It's made of something we can't touch or observe directly. Dark matter. Dark matter is thought to make up about 85% of all matter in the universe. It doesn't emit or absorb light, but its gravity is unmistakable. It sculpts the cosmic web, draws galaxies together, and holds entire clusters in its invisible grip. Without it, the large-scale structure of the universe simply wouldn't exist. The filaments we see are just faint traces of light wrapped around this ghostly framework. Astronomers can't see dark matter directly, but they can map its influence. They watch how galaxies move, how light from distant sources bends a phenomenon known as gravitational lensing. Like wind-shaping dunes, dark matter shapes the cosmos even if we can't see the wind itself. The haunting truth is that almost everything we can see is just a thin layer clinging to something far bigger and more mysterious. Every galaxy, including Milky Way, orbits inside a massive halo of dark matter. These halos stretch far beyond the visible edges of galaxies like vast unseen spheres of gravity. And yet we still don't know what dark matter actually is. It could be undiscovered particles, exotic physics, or something stranger still. All we know is that it shapes the universe while remaining hidden, like a skeleton beneath skin. When you look up at the stars, you're not seeing the true shape of the cosmos. You're only seeing the faint glowing threads draped over something much darker, much deeper, and far more powerful. If dark matter is the skeleton that holds the universe together, then dark energy is the force pulling it apart. This mysterious component makes up nearly 70% of the cosmos, and yet we don't know what it is. It doesn't behave like ordinary matter or radiation. It doesn't clump, doesn't glow, doesn't interact with light, but we can see its fingerprints everywhere in the way galaxies are moving away from one another at increasing speed. For billions of years, gravity has pulled matter together, building galaxies and clusters weaving the cosmic web. But something changed. About 5 billion years ago, the expansion of the universe began to accelerate. Instead of slowing down under the weight of its own mass, the cosmos started to speed up as though pushed by an unseen hand. That push is attributed to dark energy. The terrifying part is its quiet inevitability. As the expansion accelerates, galaxies drift farther and farther apart. Light from distant galaxies stretches, fades, and eventually disappears beyond the cosmic horizon. One day, countless galaxies will slip away faster than light can reach us. The universe will grow darker, colder, and more isolated. We don't know what dark energy really is. It could be a property of space itself, a field filling the universe, or a sign of deeper physics we haven't yet uncovered. What we do know is that it dominates everything. The stars, galaxies, black holes. All of them are just a thin layer of matter carried along by something far larger. The greatest threat in the cosmos may not be something violent or sudden. It may be this, a slow, unstoppable expansion that rips the universe apart not with fire, but with silence. The universe wasn't always cold. In its early ages, galaxies bloomed with newborn stars burning bright and fierce. But stars are not eternal. Over time, they exhaust their fuel and die. One by one, the night sky will dim. In the far future, the last great epoch of stellar birth will end and the long winter of the cosmos will begin. When star formation slows, the brilliant spiral arms of galaxies will fade. Nebulae will disperse into the void, their raw material for new stars spent. The great furnaces of the universe will cool, leaving only faint red dwarfs burning slowly in the dark. These small stars can live for trillions of years, far longer than anything shining today. But even they will eventually go dark. As the last stars die, the night sky will lose its constellations. What remains will be cold remnants, white dwarfs, neutron stars, black holes drifting in silence. The Milky Way will no longer glow as a river of light. It will be a graveyard of stellar corpses orbiting through a frozen void. For any civilization that might exist in that distant future, the cosmos will look fundamentally different. No bright galaxies, no nearby suns, just scattered embers slowly fading away. Energy, once plentiful, will become the rarest resource in the universe. This is not speculation for next century or next millennium. This is the cosmic timeline stretching forward trillions of years. The end of starlight is not a sudden disaster. It's a slow, inevitable, fading along winter that no one can stop. The monsters of the present black holes, supernova, gamma-ray bursts may seem terrifying, but in the far future they will be replaced by something quieter, colder, and perhaps even more chilling. A universe without stars. When the last stars burn out, the universe will not end in an explosion. It will end in silence. Over unimaginable spans of time, energy will spread thinner and thinner until there's no place left where anything interesting can happen. This is the heat death of the universe. Not a violent apocalypse, but a slow, inevitable dimming of everything. In this far future, galaxies will no longer shine. Black holes will no longer have stars to feed on. Planets, if they still exist, will drift alone through frozen darkness. The temperature everywhere will settle close to absolute zero, where particles barely move and time itself loses any sense of change. Entropy. The gradual increase of disorder drives this fate. Right now, the universe still has regions of high energy, star supernova jets, collisions. But entropy ensures that energy always spreads out, never concentrating again. Over trillions of years, all differences in temperature will fade. No energy gradients, no heat, no life, no movement. just a vast dark equilibrium. Black holes will be the last giants to rule this silent era, but even they will not last forever. Through the slow whisper of Hawking radiation, they will evaporate into nothing. One by one, the universe's last structures will dissolve until even space itself is left, with only a thin mist of particles drifting in darkness. This is not a doomsday we can see or feel. It is written into the laws of thermodynamics, a quiet destiny of maximum entropy, a universe where not even monsters remain. The most terrifying fate of all may not be destruction, but emptiness without end. There is another possibility, one even more terrifying than the slow cold death of the cosmos. If the dark energy that drives cosmic expansion keeps growing stronger over time, it won't just push galaxies apart, it will tear the very fabric of the universe itself. This scenario is known as the Big Rip. In this future, the acceleration of cosmic expansion doesn't slow down or level off. It increases without end. First, galaxies drift away from each other so fast that light from neighboring clusters fades beyond reach. Then, over billions of years, entire galaxies are pulled apart, their stars scattered into isolation. But the tearing doesn't stop there. As the expansion speeds up, it eventually overwhelms the gravitational bonds holding solar systems together. Planets will drift away from their stars. Moons will leave their planets. Even stars themselves will be shredded, their plasma stretched thin across the expanding void. In the final moments, the force of expansion will outpace even atomic bonds. Molecules will unravel, atoms will be torn apart, even subatomic particles will be ripped away from one another. The very fabric of space-time will split, and then there will be nothing left to hold anything together. This is not a certainty. It depends on the true nature of dark energy, something we still don't fully understand, but the equations show it's possible. The universe may not end with a quiet fade into darkness. It may end with everything ripped apart. In such a future, there would be no monsters left to fear. The universe itself would become the monster. Among all the possible fates of the universe, one stands out not for its violence, but for its sheer suddenness. If the structure of reality is not perfectly stable, then space itself could collapse into a lower energy state. This terrifying scenario is called vacuum decay. The vacuum of space is not truly empty. It holds a certain amount of energy, and our universe may exist in what physicists call a false vacuum, a state that looks stable but isn't the absolute lowest possible energy. If that's true, then one day at some random point in space a bubble of true vacuum could form. In an instant it would expand outward at the speed of light, rewriting the laws of physics as it goes. Everything inside the bubble would be reshaped by the new vacuum. Atoms would not survive. Molecules wouldn't hold together. Forces that define matter-light. And life could be erased or replaced with entirely different rules. And because this bubble travels at light speed, there would be no warning, no escape. By the time it reaches us, it's already over. This sounds like science fiction, but it's a serious possibility within modern quantum field theory. Calculations involving the Higgs field suggest that our vacuum may indeed be metastable, balanced on a cosmic knife's edge. The odds of collapse may be incredibly small, but the universe has time on its side. Vacuum decay doesn't roar like a supernova or burn like a star. It simply rewrites reality in absolute silence. No survivors, no warning, just a new universe governed by new laws expanding into the old one's remains. The most terrifying threats are not always the loudest. Some of them travel at the speed of light and make no sound at all. The universe is not silent. Even when stars don't shine and galaxies seem still, space-time itself can ripple. These waves are faint but real disturbances created when massive objects collide, twist or merge. They are called gravitational waves, and they carry the imprint of some of the most violent events in the cosmos. When two neutron stars spiral into each other or two black holes merge, their immense gravity shakes. Space-time like a drum. The waves spread outward at the speed of light, crossing galaxies and billions of years without fading completely. We can't feel them with our senses, but detectors on Earth have caught their tiny echoes, faint stretching and squeezing of space far smaller than the width of a proton. But the scale of these events is anything but small. A black hole collision can release more energy and gravitational waves in a fraction of a second than all the stars in the observable universe emit in light during the same moment. The space between galaxies becomes a sea of these ripples, quiet but unimaginably powerful. The eerie thing about gravitational waves is that they don't burn, explode, or scream. They pass through everything, through stars, through planets, through us, and they do it without leaving a trace unless we have the instruments to listen. They are invisible messages from cosmic disasters long past reaching us millions or billions of years after the fact. The universe doesn't just contain storms. It is a storm, a vast ocean of space-time where unseen waves are always moving even when the night looks calm. We are floating inside that sea, carried by the echoes of collisions we will never witness. Even in the quietest corner of the cosmos, we are not truly alone. At every moment, trillions of particles are streaming through your body without leaving a mark. They are called neutrino ghost-like messengers created in the cores of stars in supernovae in the first seconds after the Big Bang itself. Neutrinos are strange. They are incredibly light, almost massless, and barely interact with ordinary matter. A wall of solid lead light-years thick would hardly slow them down. They slip through planets, stars and galaxies as if they were made of mist. Right now, every second, billions of neutrinos pass through your body through the Earth and continue into the night without even noticing we exist. The cosmic neutrino background, a relic from the early universe, still fills all of space. It's like a faint afterglow, colder, quieter, and harder to detect than the cosmic microwave background. Long before stars formed, neutrinos were already out there flooding the cosmos. In a sense, they are older than light itself. They may not burn like gamma rays or tear space like black holes, but their very nature is unsettling. They are everywhere. They move almost at light speed, and for most of the universe's history, they have been silent witnesses to everything. They remind us that even in emptiness, something is always passing through. We live inside a sea of invisible particles, a tide that flows through galaxies, through stars, through us. A tide that began in the first heartbeat of the cosmos and will continue long after the last star fades. Every second, Earth is bombarded by a rain of high-energy particles from deep space. They travel at nearly the speed of light, tearing through the void like invisible bullets. These are cosmic rays, fragments of atoms accelerated to extreme energies by violent astrophysical events like supernova gamma ray bursts and supermassive black hole jets. Most of these particles are harmless at ground level, where Earth's atmosphere and magnetic field shield us. But in space or on a world without protection, they are dangerous. They rip through living cells, damage electronics, and leave a constant invisible storm of radiation. An astronaut on an unshielded spacecraft would face a relentless cosmic rain, a quiet, steady assault from across the galaxy. Some cosmic rays carry energies so high they defy easy explanation. A single particle can strike with the force of a baseball pitch compressed into something smaller than an atom. Scientists still debate how the universe accelerates matter to such speeds. Perhaps shock waves from distant supernovae, perhaps powerful jets from galaxies, perhaps something stranger. These particles are ancient. Some began their journey before Earth existed. They've crossed billions of light years, dodged stars and nebulae, curved through magnetic fields, and finally collided with the thin shell of our atmosphere, where they trigger brilliant showers of secondary particles. We live beneath this invisible storm, usually unaware of its presence. But in the vastness of space, cosmic rays are constant companions. They are neither loud nor dramatic. They are quiet, persistent reminders that the universe is not a gentle place, and that even in darkness something is always moving. Before the first stars were born, there was a time when the cosmos was completely dark. After the Big Bang, the universe expanded and cooled. For hundreds of millions of years, there were no suns, no galaxies, no light. Hydrogen and helium atoms drifted in the cold, silent void. This era is known as the Cosmic Dark Ages. In that time, the universe was transparent but black. Light from the early plasma had stretched into long, invisible microwaves. No new sources of brightness had appeared yet. If a human could stand in that young universe, though of course none existed, they would see nothing at all. Just infinite darkness. The only activity came from the slow pull of gravity quietly gathering matter into the seeds of galaxies. Over time, these clumps grew denser. Hydrogen clouds collapsed and the first stars flickered to life. Their light pierced the dark like sparks in a black ocean. They reionized the surrounding hydrogen, turning the universe transparent again and transforming it forever. But before those first lights, the universe was an empty stage waiting in silence. A darkness so deep it's hard to imagine not the night sky we know dotted with stars, but a sky with nothing at all. And as the cosmos continues to expand and cool in the distant future, astronomers believe it will eventually return to a similar state. Not a beginning this time, but an end. Another dark age when all light has faded and the universe becomes what it once was, a silent, starless void. The long cosmic night finally ended when the first stars were born, roughly a few 100 million years after the Big Bang gravity gathered hydrogen into massive clumps, and deep inside these clouds the pressure became unbearable. Nuclear fusion ignited and the first stars burst to life, brilliant short-lived giants far larger and hotter than our sun. This moment is known as cosmic dawn. Their light did more than just shine. It transformed the universe. These early stars flooded space with ultraviolet radiation, stripping electrons from surrounding hydrogen atoms in a process called reionization. The fog that once filled the cosmos cleared and light could finally travel freely. The first galaxies began to form, and the dark universe became a glowing web of matter and energy. But these were not gentle suns. The first stars were fierce and unstable, living for only a few million years before exploding in titanic supernovae. Their deaths enriched the cosmos with heavier elements, the ingredients from which planets, atmospheres, and eventually life would emerge. From that moment on, darkness would never fully claim the universe again. Light became part of its structure, carried by stars, galaxies, and quasars across billions of light years. The cosmic dawn marked both the beginning of illumination and the beginning of danger. The first powerful radiation, the first stellar explosions, the first forces capable of reshaping space itself. What makes this moment haunting is its symmetry. A universe that began in darkness was lit by brief, brilliant flames, and in the far future those flames will one day fade again. First light and last light are not separate stories. They are the same arc played out over cosmic time. We often imagine cosmic danger coming from distant corners of the universe. Titanic explosions, invisible voids, and black holes light years away. But some of the most real and immediate threats lie much closer to home. In the quiet darkness of our own solar neighborhood, there are objects moving silently following orbits that sometimes cross dangerously close to Earth. These are near-Earth object asteroids, comets, and other space debris whose paths intersect with our planet's orbit. Most are small, harmless pebbles that burn away in the atmosphere, but a few are big enough to reshape the planet's surface, disrupt the climate, and wipe out entire species. The Earth has already faced these threats before. 66 million years ago, a single impact at what is now Chicxulub crater ended the age of the dinosaurs. The blast unleashed energy equal to billions of nuclear bombs, filling the atmosphere with dust and ash, triggering global cooling and collapsing ecosystems in a matter of months. And that was just one rock. Today, thousands of near-Earth objects have been detected and tracked, but not all. Some are small enough to evade early detection, but still large enough to cause regional devastation. Others approach from the direction of the sun, hidden in its glare until it's too late to react. A collision with even a modest-sized asteroid could flatten entire cities or darken skies for years. We often look outward with wonder, imagining alien horrors at the edges of the universe, but the most realistic cosmic threat might not come from a distant galaxy. It could be quietly orbiting nearby, waiting for its path to cross ours at the wrong moment. Asteroids aren't the only visitors that can threaten our world. Far beyond the orbit of the outer planets lies a vast dark reservoir of frozen objects, the Oort cloud. From this deep and ancient reservoir, icy bodies sometimes fall toward the sun, drawn in by its gravity. When they do, they streak through the solar system as comet beautiful in the night sky, but potentially deadly. Unlike most asteroids, comets are unpredictable. Their long looping orbits can last thousands or even millions of years, and many approach the inner solar system without warning. A single large comet moving at incredible speed carries energy that could devastate the planet. Unlike a slow, rocky asteroid impact, a cometary strike would unleash explosive force far greater enough to trigger global firestorms and atmospheric collapse. What makes comets especially dangerous is how hard they are to spot. Many approach from the direction of the sun, hidden in its glare until they are already close. Others plunge inward from such distant orbits that no telescope can track them far in advance. We might have only months or even weeks to prepare. Our ancestors looked at comets with fear, seeing them as omens. They were right to be uneasy. While their glowing tails are breathtaking, comets are messengers from the dark edge of the solar system, ancient fragments of ice and rock that occasionally deliver extinction-level blows. The most terrifying cosmic threats are not always far away. Some are orbiting patiently, waiting for gravity to nudge them toward us silent watchers on the cold frontier of the sun's domain. Not every danger comes from flying rocks. Some comes from stars themselves. Within a few hundred light-years of Earth, there are massive stars quietly burning through their lives. One day, some of them will end in spectacular, violent explosions. The most famous example is Betelgeuse, a red supergiant more than 600 light-years away, nearing the end of its life. When it goes supernova, it will blaze brighter than the full moon in our sky. Betelgeuse isn't close enough to destroy Earth, but it's a reminder of a larger truth. The galaxy is filled with massive stars, and some of them are closer than we like to imagine. A supernova occurring within about 30 light-years could strip away part of our ozone layer, flood the atmosphere with high-energy radiation, and trigger ecological collapse. Events like this have likely happened in Earth's distant past. Unlike asteroid impacts, there's nothing we can do to stop a nearby supernova. If it happens, it happens. All we can do is watch the sky change as a new terrible star outshines everything around it. And it wouldn't be the light itself that kills us, it would be the wave of radiation that follows. Astronomers constantly monitor the life cycles of nearby stars, tracking their size, temperature, and brightness. But stellar death is unpredictable. A star can burn steadily for millions of years, and then die in a heartbeat, its light reaching us long after the explosion actually happened. We often think of the night sky as eternal and unmoving. In reality, some of those bright, steady points are time bombs ticking away in silence, waiting for the moment they collapse and send their final scream across the void. Some stellar deaths don't just end in light, they end in beams. When a massive star collapses in just the right way, it can unleash a gamma-ray burst, a tightly focused jet of energy travelling at nearly the speed of light. If one were to point directly at Earth, even from thousands of light-years away, it could strip away the ozone layer and flood the surface with radiation. Life wouldn't stand a chance. Unlike a supernova's broad wave of light, a gamma-ray burst is a sniper shot. Most explode harmlessly in distant corners of the universe, their jets never coming near us. But in a galaxy filled with billions of stars, the chance is never zero. And if such an event were aimed at our world, we would have no warning. The burst would arrive before any telescope could detect it, changing the atmosphere in seconds. The most dangerous bursts come from rapidly spinning, collapsing stars or merging neutron stars. These events are rare, but they're so powerful that we can detect them from billions of light years away. They're among the brightest phenomena in the universe, briefly outshining entire galaxies. What makes this threat unnerving is how quiet it would be. There would be no visible star in the night sky announcing its arrival. The first sign would be an invisible wave of gamma radiation tearing into the upper atmosphere. The sky might remain clear and blue even as the chemistry of the air began to shift. We live in a cosmic shooting range, but the bullets are fast and silent, and if one ever finds its mark, there is no shield to hide behind. Every threat we've explored, from black holes to gamma-ray bursts, from dark energy to nearby impacts, shares one haunting truth. None of them require our permission. The universe isn't aiming at us, but it doesn't need to. We live inside a cosmic shooting gallery where chance decides everything. For every quiet patch of night sky, there are invisible objects moving, distant stars ticking toward collapse bursts of energy, racing toward unknown destinations. Most will never touch us. Some might pass silently by, and a few at random without malice could change everything. Astronomers map these dangers, but they can't predict them all. Many asteroids are too small to track until they're close. Many stars will die without warning. A gamma-ray burst could arrive tomorrow or a billion years from now. The universe does not issue announcements. This uncertainty is what makes the cosmos so terrifying and so beautiful. We are fragile creatures living on a tiny world, shielded by chance, floating between forces we barely control. And yet, against all odds, we've survived long enough to understand the storm around us. The night sky isn't just a canvas of distant stars. It's a vast, unpredictable machine, ancient, powerful, and indifferent. To live here is to play the cosmic lottery, where survival depends not on strength, but on time, distance, and luck. For now, we survive, not because the universe is safe, but because Earth is wrapped in a thin layer of protection. Our atmosphere and magnetic field form a fragile shield against the chaos beyond. This magnetic bubble deflects most of the cosmic rays and solar particles that would otherwise strip our atmosphere bare. It keeps our oceans from evaporating, our skies from burning, and life from being erased in an instant. But this shield isn't permanent. Earth's magnetic field has flipped many times in the past, weakening during the process. When that happens, radiation from space can reach lower altitudes, exposing the surface to more cosmic energy. Even today, during strong solar storms, charged particles can disrupt satellites, blackout power grids, and damage technology that modern civilization depends on. This shield also protects against subtler dangers. Solar wind. A stream of charged particles constantly flowing from sun would gradually erode our atmosphere without a magnetic field. It happened to Mars billions of years ago, leaving behind a cold, airless desert where a living world might once have been. The protection Earth provides is delicate, balanced on invisible forces we barely control. It could be disrupted by intense solar activity, magnetic reversals, or events we don't yet understand. The monsters of space don't always need to strike directly. Sometimes all it takes is for our shield to thin, and the universe outside will do the rest. Right now, every star we see, every breath we take, every moment of peace on this blue world exists because that thin barrier still holds. But it will not last forever. For all the dangers lurking in the universe, one truth often goes unnoticed. Earth's safety is built on a knife's edge. Our planet follows a narrow, stable orbit around Sun inside the so-called habitable zone. A slight shift closer and oceans would boil. A small drift farther and they would freeze solid. Gravity, temperature, and radiation all balance here with fragile precision. But that orbit is not guaranteed forever. Gravitational nudges from other planets, particularly Jupiter, slowly reshape Earth's path over time. These changes are small now, but over tens or hundreds of millions of years, even subtle shifts could tip our climate toward extremes. Meanwhile, the sun itself is evolving. As it ages, it will grow brighter and hotter. One day it will push the habitable zone outward, leaving Earth behind. Our orbit is also vulnerable to external forces. A passing star could in principle disturb the solar system's architecture, subtly changing the trajectories of planets. A massive object crossing near the outer system could fling comets inward, or shift orbital resonances, creating chain reactions over millions of years. Right now, we live in a cosmic equilibrium that feels permanent only because it fits neatly within our short human timescale. But the universe doesn't promise stability. Earth's orbit is a temporary alignment in a restless solar system itself, moving through a restless galaxy. The danger isn't just out there, it's built into the fragile balance that makes this world what it is. All the threats we've crossed so far, black holes, cosmic voids, dark energy, deadly radiation, and the fragile shield of our own planet have one thing in common. None of them are aimed at us. The universe is not hostile in the way a predator is. It's something far colder. It's indifferent. A black hole doesn't hunt. A gamma ray burst doesn't choose a target. A wandering comet doesn't care whether a planet is in its path. These forces existed long before Earth formed and will continue long after it's gone. Life here survives not because the cosmos is gentle, but because for a fleeting moment we happen to sit in a narrow band of safety. Our world orbits a stable star. Our atmosphere shields us from radiation. Our galaxy hasn't yet torn itself apart. But this balance isn't permanent. It's borrowed time written on a cosmic clock far bigger than us. A single ripple, a star's death. A shift in orbit, a passing object could break it in an instant. For most of the universe, danger isn't an event. It's the background. It's the default state of everything that exists. Life is the anomaly here, fragile temporary clinging to a calm patch in an endless storm. The deeper we look into space, the clearer this truth becomes. The universe does not protect us. It doesn't need to. It simply moves forward with or without us. Life on Earth exists only because countless conditions align with extraordinary precision. A stable orbit around Sun, a protective magnetic field, a temperate climate, a calm corner of the Milky Way far from the galaxy's violent core. Remove any one of these and the thin thread holding our world together begins to unravel. When we look at the vastness of space, what's striking isn't just how dangerous it is, it's how astonishingly unlikely our safe haven is. Most planets are too hot or too cold. Most stars are too unstable. Most regions of galaxies are bombarded with radiation or gravitational chaos. We live not in a typical environment, but in a narrow window carved by chance and time. That window will not stay open forever. As the sun ages, its brightness will increase, slowly pushing the habitable zone outward. In a few 100 million years, Earth may no longer support complex life. Our planet will grow hotter, oceans will evaporate, and the fragile balance that sustains us will slip away, not through catastrophe but through inevitability. This is the cruel symmetry of the cosmos. For a brief moment it allows life to exist, and then it moves on. The threats we fear are not interruptions to some natural harmony. They are the natural state. It's the harmony that's the miracle. We are clinging to a fragile thread in a storm that has raged for billions of years. A storm that will keep raging long after we're gone. On clear nights, the stars seem calm and eternal, but that stillness is an illusion. Beyond the thin atmosphere, the cosmos is in constant motion. Stars are being born and dying. Black holes are devouring matter. Voids are widening. Galaxies are colliding. Gravity is pulling, light is stretching, and energy is whispering across billions of light years. We live under this storm without feeling it. Earth's atmosphere, our orbit, and the scale of time give us a false sense of stability. But the universe is always moving. The Milky Way is drifting toward the Andromeda Galaxy. Galaxies around us are flowing toward the Great Attractor. Space itself is expanding, carrying everything on invisible currents we cannot resist. Our world is like a tiny boat floating in an endless, restless sea. The waves are too vast for us to feel directly, but they shape everything from the birth of stars to the ultimate fate of the cosmos. This is why the universe is so terrifying. Not because it is cruel, but because it is relentless. It doesn't pause. It doesn't wait. It doesn't notice. We are temporary passengers in a storm that began nearly 14 billion years ago. And the most frightening part isn't the roar of the cosmic sea. It's the silence beneath it, the quiet truth that this storm will outlast everything we know. Every danger we've explored, every black hole, every burst of radiation, every wandering rock is part of a cosmos that doesn't care who sees it. Long before life appeared on Earth, stars lived and died in silence. And long after the last voice fades, the universe will continue vast and unblinking without a single pair of eyes to watch it. We are for now its rare witnesses. Life is not the rule, but the exception, a brief flicker in the darkness. The stars that seem permanent will fade. Civilizations, if they arise elsewhere, will come and go like sparks on the surface of an endless ocean. The void will remain. This thought isn't meant to be despairing. It's simply the scale of reality. The cosmos existed for billions of years before us, and will exist for trillions after. Even the grandest empires of 1,000 civilizations would be a heartbeat in its timeline. One day the last star will cool, the last black hole will fade, and when that happens there will be no one left to name the constellations, no one to speak of the light. The universe doesn't need us to continue, it simply will. That's what makes it terrifying, not its anger but its indifference. And yet in this brief moment, against all odds, we're here to look up and see it. The universe does not need to hate us to destroy us. It doesn't need anger or malice or intention. All it needs is time. Black holes spin, stars steam, space stretches, gravity pulls, radiation drifts. And through it all our tiny planet clings to its fragile orbit, shielded for now by sheer luck and thin protection. Every cosmic danger we've traced, from the crushing gravity of a black hole to the silence of a cold void, is part of the natural flow of existence. None of it is personal. None of it is directed. It's simply how the universe works. And yet that's exactly what makes it terrifying. There's no negotiation with time dilation. No pleading with a gamma-ray burst. No shelter from dark energy. The universe doesn't rage at us. It doesn't even notice. But in this indifference, there's also a strange kind of clarity. We're here in a narrow window between creation and oblivion, looking outward with minds capable of understanding. In a universe that doesn't care, our awareness is rare, precious, fleeting. The night sky isn't looking back at us, but we are looking at it, and that may be the only thing that truly belongs to us. Every structure in the cosmos has an expiration date. Stars live for millions or billions of years, then fade or explode. Galaxies grow, collide, and eventually fall silent. Even the grand web of the universe, the cosmic architecture itself, will someday unravel into darkness. Our own world is no exception. Sun will burn for only so long. One day it will swell into a red giant, swallowing the inner solar system, including Earth. Long before that happens, rising temperatures will boil the ocean, strip away the atmosphere, and erase everything we know. No technology, no shield, no miracle can stop the fundamental evolution of a star. Civilizations, no matter how advanced, exist inside this ticking clock. Even if humanity builds cities among the stars, even if we survive impacts, bursts, or darkening skies, we will still be travelers in a universe that gives us time, not permanence. The same stars that light our nights are slowly burning out. The same galaxies that fill our telescopes are drifting apart. The universe isn't cruel, but it has no patience. It will keep moving when we're gone. All that we build, all that we love, all that we dream is temporary, a flicker in an ocean of time. And yet that flicker is real. For this moment, we're here against impossible odds, alive in a cosmos that almost never allows it. For all its power, the universe has one weakness: it doesn't care. And because it doesn't care, it also doesn't stop us. It doesn't prevent us from building, from learning, from reaching out into the dark. We can't silence black holes or freeze the march of entropy, but we can understand them, and that is a kind of quiet rebellion. Every equation written, every telescope pointed upward. Every spacecraft leaving Earth is a small act of defiance against cosmic inevitability. We can't control the stars, but we can map their deaths. We can't tame gamma-ray bursts, but we can know when they happened. We can't escape time, but we can mark it. Knowledge does not save us from the storm, but it lets us face it with open eyes. We are fragile, but not powerless. Even the faintest understanding is extraordinary in a universe where most of existence is cold, empty and silent. Life doesn't last forever, but awareness transforms it into something more than survival. Against the backdrop of black holes and dying stars, our brief spark is a statement. We were here, we saw it, and in a cosmos where almost nothing sees back that might be the most remarkable thing of all. For billions of years the universe existed in silence. Stars burned, galaxies collided, black holes devoured everything around them and no one was there to notice. Then on a small world orbiting an ordinary star, something extraordinary happened. A species opened its eyes and looked back. We are not powerful compared to the cosmos. We're a brief moment in its history, a spark in an endless night. But we carry something the universe almost never makes awareness. We have built instruments to catch whispers from ancient stars, to trace the faint echoes of the cosmic microwave background, to measure the slow breathing of space-time itself. That awareness does not make us safe. It doesn't shield us from asteroid supernovae or the quiet expansion of dark energy, but it does give our existence meaning that no black hole can erase. We can see the storm. We can name it. We can remember it. The universe will keep moving long after we're gone, but for this moment it is not entirely silent. Through us it knows itself. Through our eyes it is briefly seen. Through our minds it is briefly understood, and in that fleeting act of recognition, a fragile world in a dangerous universe becomes something extraordinary, a place where the light finally looks back. We have always looked up at the night sky with a mix of awe and fear. Long before telescopes, before equations, before names for the stars, we were watchers, tiny beings on a fragile world sensing the immensity around us. The dangers of the universe existed then just as they do now, but something changed when we began to understand them. We are no longer staring blindly into the dark. We've learned to listen, to catch the faint pulses of distant pulsars, the ripples of merging black holes, the stretched light of galaxies born billions of years ago. Every discovery is a whisper from the cosmos carried across unimaginable distances, and every whisper makes the universe less unknown, even if it never becomes less dangerous. But knowledge doesn't erase fear, it sharpens it. It shows us how fragile we are, how narrow our window of safety truly is. It makes the night sky feel bigger, colder, and more indifferent. Yet it also reveals something extraordinary. In a universe that doesn't care, we are the ones who do. We may never conquer the cosmic storm, but we can watch and remember and understand. And for as long as we do, the void will not be completely silent. It will be illuminated not by stars, but by the brief, fierce light of minds that dared to look back. There is a moment that comes to everyone who truly looks into the night sky, the realization that beauty and danger are intertwined out there. The same stars that fill us with wonder are ticking toward their deaths. The same calm void that seems peaceful is cold, hostile, and endless. Every glowing galaxy is both a miracle of creation and a machine of destruction. This is the thin line between awe and terror. We are mesmerized by the swirling arms of Milky Way, by the glow of distant nebulae, by the silent elegance of the cosmic web. But behind that beauty hides radiation, collapsing stars, rogue worlds, and black holes waiting in the dark. To look at the universe honestly is to feel both wonder and fear at the same time. And maybe that's what makes us human. We don't just see the universe. We feel it. We give meaning to light that doesn't care if it's seen. We tremble before forces that don't even know we exist. And yet we keep looking. The cosmos doesn't offer comfort. It offers scale. It offers truth. And standing at that edge, small, fragile, aware, is both terrifying and magnificent. It's what it means to be alive in a universe that is stranger than we imagined. Even when we build the most powerful telescopes, even when we listen to the faintest signals, there is something about the universe that never changes. It's silence. It is not the kind of silence you find in an empty room or in a pause between breaths. It is deeper, older, and far more complete. A silence woven into the fabric of space itself. Light takes billions of years to travel. Signals stretch and fade as they cross expanding space. Even if other civilizations once existed, their voices may have been swallowed by the distance long before we ever appeared, and so we point our instruments outward and what comes back is mostly nothing. Just the soft hiss of the cosmic microwave background, the afterglow of creation itself. This silence is not cruel, it's simply the way the universe works. Stars die without applause, galaxies collide without witnesses, whole worlds freeze in the dark and are forgotten, and someday Earth may join that silence too. But right now we are still here, still listening, still watching. In a cosmos vast enough to drown out every sound, our brief existence is a small but stubborn interruption, a whisper beneath the roar of entropy. The universe will keep its silence, but we fragile, curious temporary will not stop asking questions into the void. Out of all the darkness, all the danger, all the indifferent forces that shape the cosmos, something unexpected happened. Life appeared. On a small rocky world orbiting an ordinary star, chemistry turned into biology, and biology became awareness. In a universe built on chaos and gravity, something began to wonder why it existed. This is not the natural state of the cosmos. The natural state is silence, cold and void. The odds of molecules aligning in just the right way on a world shielded just enough from radiation, in an orbit neither too hot nor too cold, are almost impossibly small. Yet here we are, a brief unlikely spark flickering against the endless night. For most of the universe's history there was nothing to notice its own beauty. For most of its future there will be nothing again. This short window of awareness is fragile, but it is also extraordinary. It turns the universe from a silent storm into a story. It gives meaning to stars that never ask to be named. We fear the darkness because it's vast, but we exist because somehow, improbably in one corner of that darkness, life beat the odds. That is what makes both the cosmos and our place in it so terrifying and so precious. In a universe filled with endless stars, it's easy to assume that life and intelligence must be common. But when we look deeper, that assumption begins to fracture. For nearly 14 billion years, the cosmos has expanded, burned, collapsed, and cooled. For almost all of that time, there was no one to see it. Life requires an extraordinary alignment of coincidences, a stable star, a quiet galactic neighborhood, the right chemistry protection from radiation, and enough time for complexity to emerge. Intelligence is rarer still, a fragile spark that may flicker only briefly before being extinguished by its own world or by the cold indifference beyond it. When we search the skies, we don't hear a chorus of civilizations. We hear silence. The vastness of the universe is not crowded with voices, it's empty, and that emptiness has a name. The Fermi paradox. It is the dissonance between the mathematical likelihood of intelligent life and the deafening absence of any sign of it. Perhaps the silence means we are early. Perhaps it means civilizations bloom and then die quickly, leaving behind no trace. Or perhaps the universe simply doesn't create minds often. Whatever the reason, it reminds us how precarious our place truly is. The dangers we've explored aren't just threats to our planet. They are threats to something far more fragile, the brief and improbable existence of awareness itself. If intelligence is rare, then survival is rarer still. Civilizations may emerge from the darkness, build their worlds, lift their eyes to the stars, and then vanish. They might be wiped out by impact starquakes, their own wars, or the quiet, unstoppable ticking of cosmic time. The Fermi paradox may not be a question of where they are, but how briefly they last. To endure in this universe requires more than intelligence. It requires resilience against threats that do not care. Wandering comets, shifting stars, radiation storms, the collapse of entire systems. A single failure, one unanticipated event can end millions of years of progress in a heartbeat. Perhaps the cosmos is littered with civilizations that reached out once briefly, then fell silent. Their signals are still racing outward at light speed, fading across the void long after their creators are gone. We may never hear them, we may only pass through their ghost light. For now we're still here, but everything that threatens them threatens us too. We are not separate from the forces that silence civilizations we're standing in their path. This is the paradox of survival in an indifferent universe. To endure, a species must be aware of dangers it did not create, and find a way to outlast a cosmos that offers no mercy. Most fail. Few ever get the chance to try. Among the many attempts to explain the Fermi paradox, one idea casts a particularly long shadow: the Great Filter. It suggests that somewhere along the path from simple life to a long-lived civilization, there is a barrier, a point at which most species fail. The filter could be at the beginning. Perhaps life itself is incredibly rare and Earth was a statistical miracle, or it could lie somewhere in the middle. The leap from microbial life to complex intelligent beings may almost never happen, but the most unsettling possibility is that the filter lies ahead of us. That intelligent civilizations arise often, but something always destroys them before they can spread. The dangers we've explored are more than background noise. They may be the filter itself. Asteroid impacts, supernovae, gamma-ray bursts, climate instability, self-destruction, all capable of wiping out fragile intelligence before it reaches the stars. This is what makes the silence of the cosmos so heavy. It might not mean no one's out there. It might mean everyone who tried failed. If that's true, then we are standing at the edge of a precipice that has claimed countless others. Our survival is not guaranteed. It's a test that almost no one passes. And if we fall, the universe will not notice. It will simply grow a little quieter. Unlike a game with retrees, the cosmos does not offer do-overs. If a civilization falls, the stars will not pause. The void will not wait. The universe simply moves on. A single asteroid can end an era. A nearby supernova can sterilize a world. A shift in climate, a burst of radiation, a cosmic accident, and a species that dreamed of the stars is erased forever. That's why the silence between the galaxies may be so profound. It isn't that intelligence never arises, it's that intelligence doesn't last. For most civilizations, the first great crisis is also the last. The dangers are unforgiving because they are woven into the structure of reality itself. Rogue planets drift, stars age, orbits shift, radiation floods space, and none of these forces care whether someone is standing in their way. Survival is not the universe's priority. It's a temporary loophole carved out by luck, timing, and resilience. We like to imagine ourselves as permanent, but the truth is harsher. We are here on borrowed time, balanced on a fragile world in a dangerous sky. And unlike stories, the universe will not give us a second chance. It never has. It never will. If civilizations don't last, then every story, no matter how advanced, ends in silence. Stars rise and fade. Worlds warm and cool. Civilizations build, reach outward, and then vanish into the background noise of time. The universe doesn't preserve their names, their languages, or their fears. It only keeps moving. Their telescopes fall silent. Their signals fade into stretched, meaningless static. The stars that lit their skies drift away as space expands. Eventually, even the memory of their existence is erased by distance and entropy. We may think of ourselves as different, more advanced, more capable, but the forces that erase them are the same ones that surround us. A universe without second chances doesn't care who is clever or who is fragile. It only endures. Perhaps other watchers once looked up just like we do now. Perhaps they feared the same black holes, the same radiation storms, the same silence, and then they were gone. If humanity fails, the universe will not mark the moment. There will be no echo, just one more voice disappearing into the void. Right now, we stand at a rare point in cosmic history, aware of the storm around us, but not yet swallowed by it. We can still see the stars, still map the dangers, still speak into the void. We live in the brief intersection between survival and oblivion, between light and the silence that follows. Everything we've uncovered, black holes, voids, dark energy impacts, radiation, is part of a universe that doesn't offer guarantees. Most species, if they ever existed, may have already crossed this threshold and disappeared without a sound. But we have something they may not have had: the knowledge of the storm itself. That knowledge does not make us invincible. It doesn't grant control over black holes or cosmic expansion, but it gives us one fragile advantage: awareness, the ability to act before the void decides for us. In a universe that gives no second chances, awareness might be the only tool that matters. This is where our story diverges. We can let the silence consume us like it did to countless others, or we can face it with open eyes. The void won't pause, but we can choose how we meet it. And in a cosmos this vast, that choice alone is extraordinary. If the universe is a vast ocean of darkness, then civilizations are sparks flaring briefly before being swallowed by the tide. For most, that spark goes unseen, but its existence still matters because it transforms the void from something completely silent into something that has been witnessed. Our spark is burning right now. Humanity exists in a narrow window of cosmic stability, with enough technology to look outward and enough fragility to know how easily it could all end. This is a rare and precious moment, one that in the universe's immense timeline will pass like a breath. This light may not last forever. It may fade through disaster, through entropy, or through time itself. But while it burns, it illuminates more than just our world. It reveals the storm for what it truly is. It turns an indifferent universe into something seen, known, named. The terrifying part isn't that our light will one day go out. It's that if we let it fade, the universe won't even notice. The comforting part, the only part that belongs to us, is that it ever burned at all. Everything we are, our cities, our technology, our stories, exists on borrowed time. Earth itself is temporary, orbiting a star that's already halfway through its life. Sun will not shine forever. The cosmic balance that makes our world habitable is not a promise. It's a brief alignment in an ancient and restless universe. Even if we survive asteroids, comets, radiation storms, and our own self-inflicted wounds, time will not stop. The sun will grow brighter. The oceans will boil away. The stars will drift farther. Darkness will reclaim the sky. Nothing can freeze the flow of cosmic time. But borrowed time is still time. Every second of it is a chance to understand, to build, to look outward. The fact that our existence is fragile doesn't make it meaningless, it makes it urgent. Civilizations that came before, if they ever did, may not have realized how brief their light would be. We have that knowledge now, and with it comes a responsibility to use this fleeting moment wisely, because the universe will not wait for us. The end of our time will not come with fanfare. The universe doesn't sound alarms. Stars change slowly. Orbits shift quietly. Radiation travels in silence. Even the most catastrophic events in space arrive without warning, unfolding across distances so vast that by the time their light reaches us, they've already happened. This is how the cosmos moves, not with sudden intention, but with a patient, unstoppable rhythm. It doesn't strike like a predator. It erodes like time itself. Every star is on a timer. Every planet, every galaxy, so are we. That truth can feel unbearable, but it's also honest. The universe does not lie. It does not offer false hope. It simply moves forward, indifferent to who stands in its path. Knowing this doesn't make us safer, but it makes our moment real. It strips away illusions and leaves behind the raw truth of existence. We are living inside a countdown we cannot pause, but the awareness of that countdown, the fact that we can name it, face it, and understand it, is something extraordinary. It means that even if the universe ends in silence, we were here to hear the ticking, Time in the cosmos is not measured by human lifetimes or civilizations. It's measured in the burning of stars, the collapse of galaxies, and the slow fading of light. Everything that lives does so between events that are far larger than itself. The sun doesn't know or care how long humanity exists. The expansion of the universe won't pause because we want more time. This is what makes the cosmos so terrifying. It doesn't rush to destroy us, but it never stops moving. Stars shift imperceptibly night by night, but across eons they drift apart and disappear. The sky we see today is not the sky our distant descendants will see. Even constellations, those ancient familiar patterns, will melt into unrecognizable shapes as the galaxy turns. We have always lived in motion, carried along by forces far beyond us. The ground beneath our feet feels still only because the clock of the universe ticks so slowly compared to our life. But nothing stands still. Not stars. Not worlds. Not us. The universe is patient. It doesn't need to act to end us. It simply waits, and in time everything changes. That's the quiet power of the cosmos, not its violence, but its endless, unstoppable flow. Every star that has ever shone, every galaxy that has ever formed, every world that has ever existed is temporary. The universe is built on impermanence. Even the most colossal structures, superclusters, filaments, the great cosmic web itself are slowly unraveling as space expands. There is no fortress in the cosmos that lasts forever. For humanity, this truth is both sobering and defining. Civilizations rise believing the world is solid and the sky eternal. But the continents shift. The stars move. The night sky that guided our ancestors will vanish into something unrecognizable. We will change or we will disappear. This impermanence is not a flaw in the universe, it is the universe. It's what allows stars to form and die, what gives birth to new worlds, what makes evolution possible. The same forces that one day will erase us are the same forces that allowed us to exist at all. It's a strange kind of weight knowing everything ends. But it's also clarity. Against this backdrop, what matters is not how long we last, but what we choose to do with the time we have. In a universe built on impermanence, meaning is something we create, not something we're given. There will come a time unimaginably far away when the universe is nearly empty, when the last galaxies drift beyond the cosmic horizon, when the last stars fade to black dwarfs, when black holes themselves begin to dissolve into nothing through the slow whisper of Hawking radiation. If any intelligent beings still exist in that distant future, they will live in a universe very different from ours. Their night sky will hold no bright constellations, no spiral galaxies, no starlight. It will be a cold, dim void where most of cosmic history has already passed. They will not be able to see the Big Bang's afterglow. They will not know the universe was once full of light. To them it will have always been dark. They would be the last observers, witnesses to the fading of everything. Their telescopes would look out into a blank, silent cosmos, unable to find the evidence of its fiery birth. Even the cosmic web itself would have been stretched too far to be seen. And if no one remains by then, if life vanishes before that distant epoch, then the universe will fade without witnesses. The great story of stars and time will end as it began, in silence. That is the weight of living in a mortal cosmos. We are not just fragile creatures. We are fragile observers standing in a brief moment when the universe can still be seen, named, and understood. The story of the cosmos begins with light, but it ends in darkness. Stars are temporary engines burning through their fuel to shine across the void. One by one they will die. The brilliant beacons that once filled the night sky will fade into cold embers. Galaxies will empty. Black holes will slowly evaporate. Eventually the universe will enter a time with no starlight at all. Astronomers call it the degenerate era, when the cosmos is ruled not by living stars but by the long shadows of their remains. White dwarfs, neutron stars, and black holes. As eons pass, even those remnants will vanish. Hawking radiation will dissolve the last black holes. Matter itself may decay. Space will stretch colder and darker than any night we can imagine. When the lights go out, there will be no sky to look at, no constellations to name, no watchers left to remember that stars ever existed. The terrifying thing isn't that the universe ends with a bang, it's that it ends with silence. We live at a privileged moment in a universe still full of light. One day even light will surrender, but for now we can still look up and see the cosmos burn. The sky we know, filled with constellations, nebulae and galaxies, is temporary. Over billions of years, the accelerating expansion driven by dark energy will push distant galaxies beyond the cosmic horizon. Their light will stretch and fade until they disappear entirely, leaving only a handful of nearby galaxies still visible. Future observers, if they exist, won't see a grand interconnected cosmos. Their telescopes will show only a cold void surrounding a few dim points of light. The cosmic microwave background will have redshifted out of detectability, erasing the evidence of the Big Bang itself. To them, the universe will appear small, quiet, and eternal, its true history hidden beyond reach. The night sky has always been our greatest source of wonder. It's how we've measured time, found our place, and begun to understand where we came from. But the sky is not fixed. It's changing slowly, silently every moment. One day the stars and galaxies that taught us to look outward will no longer be there. The universe won't end with a single cataclysm. It will fade from view piece by piece until only darkness remains. We live in a rare cosmic moment, a time when the universe is still visible, a time when the sky still speaks, and that too will pass. When the last galaxies vanish beyond the horizon, when stars fall silent and black holes dissolve, something else will fade with them, the memory of the universe itself. Every story ever told by civilizations, every observation, every theory, every trace of cosmic history is bound to fragile vessels. Data can be preserved, structures can be built, but nothing lasts forever against entropy. Over immense timescales, everything we record will be erased, whether by decay collisions or the slow expansion of space itself. Even if distant civilizations endure longer than we do, they too will face the same darkness. One day there will be no evidence left that the universe ever contained light galaxies or observers. The cosmic background will be gone. The great web will be invisible. Every clue that once revealed the story of creation will be erased. This is perhaps the most haunting truth of all. Not just that everything ends, but that everything is forgotten. The universe will not remember us. It will not carry our names, our knowledge, or our fears. It will simply fall silent again as it was before the first star was born. We are living in one of the few eras when the cosmos can still be seen, measured, and understood. One day, not even memory will remain. In the final ages of the cosmos, not only will stars and galaxies disappear, so will the evidence that they ever existed. With nothing left to carry memory, the story of the universe will end not in destruction, but in forgetting. No light, no structure, no observers, just the quiet, absolute stillness of a cosmos that has outlived everything it created. Even if civilizations arise again, if some improbable pocket of physics gives birth to new stars in a distant epoch, they will have no way to trace the past. The records of this universe, the glowing web of galaxies, the microwave background, the fingerprints of creation will be gone. It will be as if none of this ever happened. This is the ultimate terror of the universe. Not rage, not violence, but erasure. A story without a narrator. A beginning that leaves no trace at the end. We live now in one of the few eras when the cosmos can be remembered, mapped, and understood. For a brief moment we hold the past in our hands. One day that chance will vanish too, not with a bang, but with the quiet weight of nothing left to remember. In the far future, when the last stars burn their final fuel, the universe will not end suddenly. It will fade. One by one, the remaining embers will dim into black dwarfs. The glow of galaxies will dissolve into darkness. Space will stretch so wide that even the closest neighbors will vanish beyond sight. If any observers exist, then they will stand beneath a sky with no constellations. Their telescopes will find nothing beyond their own dying star. No echo of the Big Bang, no trace of cosmic history. They will live in a universe where it seems as though they are alone not just in their galaxy, but in existence itself. This isn't a poetic image, it's the physical future predicted by cosmology. The degenerate era will be followed by the black hole era, and finally by the heat death of the universe, a time when energy is too spread out to do anything. No light, no life, no sound. The last light in the cosmos will shine for no one. It will fade in silence, and the universe will return to what it was before stars ever formed. Endless, indifferent darkness. We exist now in the golden age of light, a brief moment between chaos and silence. The terror of the universe is not just what's out there, but how easily it all slips away. When the final star goes dark, the cosmos will enter an era unlike anything we can truly imagine. There will be no sunrise, no galaxies shimmering in the distance, no faint cosmic glow. The long night will begin a time when the universe is ruled not by light but by cold, by gravity, and by the slow erosion of everything. Black holes will remain as the last great architects of structure. For unimaginable spans of time they will drift silently, swallowing what little remains until even they begin to evaporate through the faint whisper of Hawking radiation. With their death, the last sources of heat and energy will vanish. This era isn't just dark, it's empty. There will be no stars to navigate by, no clues to trace cosmic origins, no witnesses to tell that galaxies once filled the sky. It will be a universe stripped down to its bones, featureless, silent, infinite. What makes this terrifying isn't only the scale of it, but its certainty. Unlike black holes or impacts, this isn't a possibility. It's the natural end written into the structure of time itself. The long night is coming, and nothing can stop it. We, by accident of history, live in an age when the universe still burns brightly. That is both a gift and a reminder. In the long night, even time seems to lose meaning. There will be no great events left, only the slow unravelling of what remains. The last black holes will take unimaginable spans to evaporate. When they finally release their final breath of Hawking radiation, there will be nothing left to shape. No stars, no planets, no structure. This era is sometimes called the Dark Era, a time when the universe is a thin fog of scattered particles drifting endlessly through ever-expanding space. Energy will be so dilute that nothing complex can ever form again. No spark will reignite, no star will return. Every trace of what once existed, galaxies, civilizations, even the memory of creation itself will have been erased. The cosmos will not end in flames or collapse. It will end in quiet, perfect stillness. And this is perhaps the most chilling truth of all. The universe doesn't need to destroy us. It only needs to outlast us. It doesn't rage, it endures. And in the end it wins, not by force, but by time. Right now, in this rare, bright age, we live in a universe still filled with light. That will not last. But knowing the ending makes the present moment, this fragile spark in an endless timeline, even more extraordinary. When the last remnants of heat fade away, the universe will become a place where nothing new can ever happen again. No light will travel, no stars will ignite, no structures will form. The vast, once brilliant cosmos will have fallen into a final, endless stillness. This is the heat death of the universe, not a violent collapse, but a quiet surrender. Energy will be spread so thin across infinite space that nothing will have the strength to change. No gravity to pull, no fusion to burn, no life to observe. It's hard to imagine this kind of silence. Every part of our world is alive with motion waves, wind, starlight, the hum of the universe itself. But in the end, even those faint background signals will fade into nothing. Time will stretch on, but nothing within it will move. It will be a universe that still exists but no longer happens. That is the last terror of the cosmos. Not destruction but absence. A sky without stars. A universe without stories. A silence so complete it erases the idea of sound. And yet we live now in the opposite of that ending, in an era of light motion and awareness. Against the certainty of silence, every flicker of existence becomes a kind of defiance. At the very end of all things, the universe will not roar. It will not collapse or scream. It will simply fade. A scattered haze of particles will drift through endless darkness. No star will burn. No black hole will remain. No trace of what once was will survive. This is the true weight of the heat death of the universe, the final irreversible quiet. Entropy will have done what no disaster, no black hole, no cosmic collision ever could. It will have erased everything. Not just life, but the possibility of life. Not just stars, but the possibility of light. If any mind were to exist in that moment, it would look upon a sky with nothing left to see. Time would still pass, but it would mean nothing because nothing could change. The story of the universe would not end with a final word. It would end with silence. But that silence hasn't come yet. We stand far from it in an age where galaxies still shine and stars still burn. We have the rare privilege to look at the universe while it is still alive with light. And that makes this moment our moment immeasurably precious. At the heart of everything we've explored, the collapsing stars, the fading galaxies, the ultimate darkness, lies a single force. Time. Time is the most patient ruler in the universe. Black holes may tear, radiation may burn, space may stretch, but it is time that wins in the end. Unlike any other force, time doesn't act. It doesn't push, pull, or burn. It simply moves forward, and everything else must follow. Stars live and die within it. Galaxies grow and dissolve inside its current. Even the most violent events, supernova collisions, explosions, are just brief moments in its flow. That's why the end of the universe isn't a single event. It's a process stretched across unimaginable spans. Time will keep flowing long after there's nothing left to change. It will outlive stars, black holes, and memory itself. And here we are, fleeting creatures with short lives, daring to measure this eternal tide. We build clocks. We count orbits. We carve meaning out of seconds that are gone as soon as they're named. In the face of a cosmos ruled by time, that act of awareness is both fragile and astonishing. Time doesn't need power to conquer the universe. It simply flows. Everything from the birth of galaxies to their eventual dissolution happens within its current. It doesn't rush. It doesn't pause. It wears everything down with perfect patient inevitability. Even the greatest cosmic forces fall before it. Dark energy will stretch the universe, but time will let it stretch forever. Black holes will swallow light, but time will let them evaporate. Stars will burn bright, but time will outlast their glow. Nothing escapes. Our lives are tiny ripples on this river. Civilizations are brief sparks on its surface. Galaxies themselves are just waves that rise and fall. And when the universe grows dark and cold, time will keep flowing through nothing. What makes this terrifying isn't its violence, but its calm. Time doesn't need to fight to win. It only needs to wait. And in the face of that endless current, everything else is temporary. Yet in this brief window, we're aware of it. We can measure it. We can feel it. And that simple awareness, that fragile spark of consciousness drifting on the river's surface, might be the rarest thing the cosmos has ever made. No matter how much we imagine controlling our future, there's one force we can't bargain with. Time. It doesn't listen. It doesn't bend. It doesn't care who stands in its way. While stars explode, galaxies drift apart, and entire civilizations rise and fall, time simply keeps moving forward. This is what makes it the most terrifying thing in the cosmos. Black holes can evaporate, radiation can fade, even the fabric of space can stretch into emptiness. But time doesn't end. When these things do, it outlasts them all. To us, time feels constant and predictable. Days, months, years. But on cosmic scales, it is merciless. It takes suns, crushes galaxies, smooths the universe into silence. Its final victory isn't loud or violent. It's patient, quiet, complete. And here we are, tiny beings clinging to a thin slice of existence, measuring seconds on a river that will outlive everything we've ever known. Time is the one monster in the universe that doesn't need to move. It only needs to wait. When everything else fades, time will remain flowing through a universe where nothing changes anymore. No stars will burn, no black holes will whisper, no galaxies will collide. The heat death of the universe will have erased not only motion, but meaning. It's hard for the human mind to grasp this kind of stillness. We are built to notice change, the rise and fall of light, the turn of seasons, the pulse of stars. But the universe's last chapter won't have rhythm or sound. It will be the quietest silence imaginable, stretched across an eternity with nothing to mark its passage. That's the final terror of time. It doesn't end. It just moves on even when there's nothing left to move with it. A river flowing through an empty landscape. And yet in this tiny bright moment of its timeline, the universe is alive with light, with gravity, with motion with us. We are here at a rare point in history, not the beginning, not the end, but in between. In the only chapter where the universe can be seen, after every star has faded, every black hole has dissolved, and every trace of life has vanished, the universe will be ruled only by time and silence. This is the final truth behind everything we've explored. The universe is not cruel, it is not kind, it is indifferent. It will not remember us nor anything that came before. It won't mark the passing of galaxies or the extinguishing of the last light. It will simply exist empty, still, and vast beyond comprehension. For some, that is the most terrifying idea of all. A universe without witnesses, without memory, without meaning. But in a strange way, it's also what makes this moment so precious. Against the weight of that indifference, our awareness, however brief, is extraordinary. We are here now in the light, in the motion, in the story. The universe may not care, but we do, and that difference, however small, is everything. In a universe destined for silence, meaning doesn't come from the stars or the void, it comes from us. The cosmos won't remember our cities, our names, or our fears, but while we are here, we can look at the night sky and give it shape. We can turn chaos into constellations. We can turn silence into stories. That is something no black hole, no gamma ray burst, no cold expanse of space can take away. The universe may be indifferent, but the act of caring, of noticing, of understanding is uniquely ours. It's how a small species on a fragile planet creates significance in a place that offers none by itself. Meaning is not written into the fabric of the cosmos. It's carved into it by those rare sparks of awareness that rise, burn briefly and fade. We are one of those sparks. Our time is short, but it is ours. In a universe without purpose, simply seeing it is a kind of defiance. Simply understanding it is a kind of victory. And simply being here right now is something the stars themselves will never know. The cosmos does not speak. It expands, it burns, it fades. Left alone, it would be a perfect, endless silence. But then briefly we appeared, a species that builds stories out of starlight and whispers its questions into the dark. Our existence is tiny compared to the scale of galaxies, but it disturbs the silence. We name the stars, we map the void, we reach outward with machines and minds that shouldn't by any cosmic standard exist at all. In doing so, we become the noise in a universe that never expected to be heard. This noise won't last forever. One day, like everything else, it will fade. But while it exists, it's real. It's proof that the universe can contain not just matter and energy, but awareness. That's what makes our moment both fragile and extraordinary. Against the backdrop of indifference, we are a brief interruption, a spark of thought in a storm of silence. And that spark, small as it is, matters because it burns at all. For most of its existence, the universe was unseen. For most of its future, it will be unseen again. But now in this narrow window of cosmic time, it is illuminated not just by starlight, but by eyes capable of looking back. We stand in an age where galaxies still shine, where the cosmic microwave background still whispers of the beginning, where the night sky still tells the story of what came before. Future observers, if any exist, won't have this view. For them, the evidence will be gone. The sky will be quiet. The universe will appear eternal, small and empty. We are among the lucky few to see the cosmos while it can still be understood, to measure its age, to glimpse its structure, to watch its light before it vanishes into redshift and darkness. This privilege is temporary like everything else, but it is real. The universe has existed for billions of years without witnesses. It will exist for trillions more after we are gone. But for this brief moment it is seen, and that changes everything. To understand the universe is to carry a strange kind of burden. We know what stars are. We know they die. We know galaxies drift apart, black holes evaporate, and time itself outlasts everything. We know the ending not of us but of everything. Awareness doesn't protect us from the storm. It doesn't shield us from supernovae or the cold expansion of the cosmos. But it gives the void a witness. It turns what would have been pure silence into something with weight, with context, with meaning. That awareness is fragile. It lives inside soft, perishable brains on a single small planet circling an ordinary star, and yet it holds the story of galaxies of space-time, of the birth and death of everything. In the scale of the cosmos, it is barely a whisper, but it's a whisper the universe didn't expect. That is both terrifying and beautiful, to be aware in a universe that is not aware of us, to know the storm even if we can't stop it, to carry the weight of understanding in a place built on silence. This moment, our moment, is not just another point on the cosmic timeline. It's a rare chapter in the universe's story, a window when stars still shine, galaxies still speak through their light, and life can still ask questions about where it came from. For most of cosmic history, there was no one to watch. For most of its future, there will be no one to remember. But we exist now in the brief intersection between beginning and silence, where the universe is not only visible but knowable. That's what gives this era its weight. It's not guaranteed. It's not permanent. It's a fragile alignment of time, matter and chance, the kind of moment that may never repeat again. And even if it does, no two witnesses will ever be the same. The terrifying thing is how easily this chapter can end, but the miraculous thing is that it exists at all. We live at the edge of something vast and unstoppable, and we can see it. That alone makes this moment more extraordinary than any star. We exist in a universe stretched between two eternities, the one before we arrived and the one after we're gone. For billions of years before us, the cosmos spun in silence. For trillions more, it will return to that silence. But in this thin slice of time, we are here aware, fragile, temporary. Every star we see is part of this moment. Every measurement, every discovery, every glance at the night sky is a whisper carved between two vast voids of quiet. We cannot stop what's coming, the fading, the darkening, the inevitable silence. But we can give meaning to the present. That's what makes this moment so powerful. It's not infinite. It's not permanent. It's ours, a moment where the universe is awake through us, where the light is still bright enough to be seen, where the story is still being written. The most terrifying truth of the cosmos isn't that it ends, it's that it goes on and we won't. But in this breath between eternities, we have something the universe itself does not. The power to know it. No matter how far the darkness spreads, there will always have been this moment. A time when the universe burned with stars, when galaxies filled the sky, when minds rose from fragile worlds to look outward. This is the light at the heart of the storm. Not eternal, not invincible, but real. The cosmos will forget it. The stars won't remember. Time will erase every trace. But that doesn't diminish its significance. The universe doesn't need to remember for something to have mattered. Meaning lives in the moment itself, in the act of seeing, of understanding, of existing at all. When future darkness falls, this light will have already been cast. It will have shaped the world, traced the cosmos, and burned for as long as it could. Even if it fades, it will have been, and maybe that is enough. In a universe that offers no guarantees, simply burning even for a moment is a kind of victory. The universe does not care that we are here. It has no memory, no intention, no mercy. And yet here we stand, breathing beneath starlight billions of years old. That act alone to exist, to see, to understand is defiance against silence, against time, against the weight of inevitability. We can't control the black holes, the dark energy, or the fading of the stars, but we can stand beneath them and know that might be the most powerful thing the cosmos ever produces. Not endless empires, not immortal structures, but a fleeting awareness capable of grasping infinity. Our existence does not change the fate of the universe, but it changes what it means. For a brief moment, the storm has a witness. When the final light fades, there will be no one to speak, no one to listen. The universe will return to what it was before stars were born, a silent expanse without memory. But before that silence comes, we have this language, thought, wonder, fear, and understanding. We give the void a voice, even if it will not last. We name the stars, even though they will die. We look outward, even knowing the universe will never look back. In the face of indifference, we create meaning. That is our last word, carved not in stone or starlight, but in consciousness itself. And though the void will swallow it for a moment, it will have been real. The universe is vast, cold, and mercilessly patient. It will outlive every star, every world, every story. But for a brief sliver of time, a spark on an endless timeline, something rose to meet it. That spark is us. We are fragile. We are temporary. But we're also the only thing the universe has ever made that can see itself, that can stand in the storm and whisper, "I was here." The most terrifying things in space are not just the monsters that lurk in the dark. It's the silence, the patience, the certainty. But the most extraordinary thing is that for a moment we burned against it. The storm will go on, but so will the spark, not in time but in meaning.